Determine all values of c that satisfy the conclusion of Rolle's theorem for the function f of x equals x squared plus 6x plus 8 on the interval -5 included to -1 included. The first thing to do is to determine whether the three conditions are met for Rolle's theorem to be applied. The first condition, the function f of x, x squared plus 6x plus 8, has to be continuous on the closed interval given. X squared plus 6x plus 8 is a polynomial. And a polynomial is continuous on any interval, so it will be continuous on the closed interval given, -5 to -1. Closed means that it includes both endpoints, indicated by the square brackets on both endpoints. Condition 1 is met. The second condition, the derivative, f prime of x, which will be first term power, we'll bring the power down, subtract 1 from it. Second term constant times x, the derivative is the constant. Third term constant with no x, the derivative is 0. The derivative has to be continuous, it's called differentiable, on the open interval. 2x plus 6 is also a polynomial, and is therefore continuous on any interval. So this will be continuous, it's called differentiable on the open interval of -5 to -1. Open means it does not include the endpoints, indicated by the round brackets on the endpoints. A function is never differentiable on the endpoints, so it's always the open interval here. Condition 2 is met. Condition 3 is that the function evaluated at the left endpoint will equal the function evaluated at the right endpoint. In this problem, we have the interval of -5 to -1. The left endpoint A is -5, the right endpoint B is -1. We are going to evaluate the function at the left endpoint and the right endpoint and see if they are the same. These can be evaluated by plugging into the function. -5 squared plus 6 times -5 plus 8. -5 squared will be 25, plus 6 times a -5 is a -30, plus 8. 25 minus 30 is a -5 plus 8, which comes out to a 3. f of -1 will be -1 squared plus 6 times -1 plus 8. -1 squared is 1. 6 times -1 will be -6 plus 8. 1 minus 6 is a -5 plus 8, which comes out also to a 3. So we have f of -5 does equal f of -1. Condition 3 holds true. All three conditions hold true here. Therefore, Rolle's theorem does apply. And Rolle's theorem will be the slope of the tangent line at some value c will equal the slope of the secant line connecting the endpoints, f of b minus f of a over b minus a. This is the result of the mean value theorem. For Rolle's theorem, we have the third condition that f of a and f of b are the same value, so when they subtract, it comes out to a 0. So Rolle's theorem is that the slope of the tangent line equals to 0. For some c in the open interval, there's going to be at least one c, perhaps more, that make this true, that will end up in that interval of -5 to -1. The left side, we want to evaluate the derivative at c. That's done by plugging the c into the derivative function. That will give 2c plus 6. The right side is a 0 for the Rolle's theorem special case of mean value theorem. We can now solve for c by subtracting 6 from both sides, dividing both sides by a 2. c comes out to a -3. Notice that that c is in the interval as it should be. There's our c value that satisfies the conclusion of Rolle's theorem for this function.